In this video, we're going to talk about elements of a sound experimental design and what makes a good controlled experiment. So what is the purpose of creating a sound experimental design? We want to answer a question that we want to solve, and we want to be descriptive enough so that anyone can repeat the experiment and get the exact same results that you get. You want to make sure to identify both your independent and dependent variables. Independent variable is the factor that you change, and the dependent variable is the factor that you measure as a result of the change. So if we consider the following questions: does fertilizer impact the germination of radish seeds? Does caffeine affect the heart rate of water fleas? Does chewing gum improve the memorization of numbers? The independent variables would be the variables that we change: the fertilizer, the caffeine, and whether or not our subjects chew gum. The dependent variables are what we're measuring as a result of the change. So in the first example, the number of seeds that germinate would be the dependent variable. The heart rate of the water fleas would be the dependent variable, and the memorization of numbers would be the dependent variable. We also need to identify the two groups in a controlled experiment that we will be testing. A good controlled experiment has a control group, and that's most experiments do, not all, but most. And this is the group that will not receive whatever the independent variable is, whatever is being tested. So these would be the groups that get no fertilizer, no caffeine, or no gum. The experimental groups are the groups that get whatever is being tested. So in our examples, these would be the groups that get fertilizer, caffeine, and gum. So the methods of the experiment should follow certain guidelines in order to be sound enough to draw conclusions from. So rule number one is everything in the experiment is constant except for the independent variables. Now this is not always possible to control, so you want to control everything that you can control. You want to eliminate the possibility of outside variables affecting the outcome. So you want to use the same number of radish seeds. For example, if we look at the impact of fertilizer on the germination of radish seeds, we want to use the same amount of water in each group. We want to wrap the seeds in the same size and type of paper towel. And we want to store the bags in the same environment, same amount of light, same temperature, same humidity, so that the only variable that is different between the two groups is the fertilizer. Rule number two, we want the sample size to be large enough. So if we only tested one seed in the fertilizer group and one seed in the control group, the seed itself could be a dead seed. It could be defective. So the larger your sample size, the more you're eliminating the possibility of errors from other variables. So what is a good number? 10 seeds is a good number. And it really depends on the type of experiment you're doing, but for this example, 10 seeds would be a large enough sample size. You should repeat the experiment and test more than one of each control and experimental group. And these are called replications. There's no hard fast rule, but you definitely need to have more than one. So 2 to 5 replications or trials might be enough. So in the case of the impacts of fertilizer on the germination of seeds, the fertilizer group could be tested 3 times, so that would be 3 bags with 10 seeds in each one. The control group could be tested 3 times, 3 bags with 10 seeds in each one. And if you were to say that the control group has 10 seeds and therefore it's repeated 10 times, that's called pseudo-replication, and that is not a true form of replication. So each of the bags needs to be separated out to be considered a replication. Rule number 4, you want to randomly choose your subjects. So there is an idea called selection bias, and selection bias is when you handpick your subjects, and so that handpicking of the subjects could introduce another factor that would impact the results of the experiment. So for example, if you were to pick out all the seeds out of a bag that were big, then that would be selection bias. Or if you were to call in a number of volunteers for the chewing gum study and you were to put all the males in one group and all the females in another group, that would be selection bias. So to eliminate the bias, you could randomly close your eyes and pick out seeds from the bag. Or in the case of the chewing gum, you could put everyone's name in a hat and randomly choose the names, and first 10 people would be in the control group and the second 10 would be randomly chosen for the experimental group, for the chewing gum group. Before you start your experiment, you want to make sure that the variables that you are going to be testing are outlined on a table, and that way you know that you are going to be testing exactly what you're going to be testing. You say you're going to test. So for example, if we were looking at the impacts of fertilizer on germination of seeds, then I would create a table with the number of seeds that germinate. Here's fertilizer baggie 1, fertilizer baggie 2, oops, I misspelled that. Fertilizer baggie 3, and each of those, remember, has 10 seeds. The control 1, control 2, control 3, and then I would be measuring these over the course of 10 or 7 days. So I could have day 1 and I would report how many out of 10 germinated, day 3 for each group. So you want to have this table done and your experimental design outlined before you start your experiment, and make sure that your teacher or mentor has approved this before you actually start your experiment. And good luck!